Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, refreshed and inspired. I hope that your presence in watching my videos, which might be important to your studies, can help me uh, energetic and willing to solve problems, present problems in video format so that many students from civil engineering can benefit from it. So if you like what I'm doing, if my videos are important to your studies, also please don't forget to subscribe. I will lecture on the force method or the flexibility method. Let's formalize it. Although I presented these ideas in the preceding problems and in the preceding methods for indeterminate structures. So I will formalize the flexibility or the force method. So the force method is also called the method of consistent deformations, which I already presented in the preceding topics, but let's formalize it now. So for example, let's consider the indeterminate beam shown below. This beam is indeterminate to the second degree, and the two conditions must be established in order to solve the problem. So for instance, we remove the redundants RA and RB and it becomes a cantilever beam which can be analyzed by the previous methods presented. So if you master the different basic methods, double integration, area moment, conjugate beam, and the two energy methods, virtual work method and the Castigliane's second theorem, then this becomes an easy job for you. So after removing the redundant forces, the reactions, the beam becomes a determinate one, which can be analyzed by the previous methods. So the structure with the original loading is called the primary structure, which deflections under its support can be found by any method already discussed. So the next step is to apply a unit upward force at A and at B, one at a time, causing it to deflect upwards. This deflection is equal to FAA. Because that is due to unit load, we must magnify that by the reaction at A for it to become the actual deflection due to the reaction at A. Similarly, we apply a unit upward force at B. By the way, the corresponding deflection at B due to the unit upward load at A is FBA, denoted by FBA. And the meaning of FAA means the unit load is at A due to the deflection at A. Then FBA is the deflection at B due to the unit upward force at A. So this is it. So this is the deflected shape after we remove the supports, the redundants. So this is FAA or delta. This is delta A rather, the actual deflection due to the actual deflection of the primary structure, and this is delta B. So for the unit upward force applied at A, then it will deflect upwards. Then this is FAA, and the corresponding deflection at B is FBA. Likewise, when the unit load is applied at B, then it will deflect upwards as shown. Then this is FBB, and the deflection here is FAB. So the deflection at A due to the unit upward load at B. So that's the definition. Then the compatibility equation will be established as the following. So we have FAA times RA plus FBA times RB, then plus delta A must be equal to 0. Again, FAA RA plus FBA RB plus delta A equals 0. Call that equation 1. And the second equation is FAB-RA plus FBB-RB plus delta B equals 0. That's equation 2. So solving these two simultaneous linear equations, and we can have the values of RA and RB respectively. Then we shall also discuss Maxwell's law of reciprocal deflections, which states that for a structure obeying Hooke's law, the deflection at a point M due to a unit applied load at a point N is equal to the deflection at N due to a unit load at N. So that's called Maxwell's law of reciprocal deflections, which can be verified and observed as we solve problems, sample problems, and applying this force method.